All right, so I think this is recording. Let's take a look at these three problems. We want to find the discriminant and state the number and type of the solutions for each of these following equations. So um, again, the first thing that I notice about all of these that they're already in standard form for us, so they're ready for us to identify A, B, and C, and then to use the formula for the discriminant. Now, what is the formula for the discriminant? Well, that comes from the quadratic formula. So our quadratic formula is the opposite of b plus or minus the square root of the discriminant. And this discriminant has a formula of b squared minus 4 times a times c. All right, so that's what we want to find in each of these problems. So in problem number 4, let's identify a, b, and c. A is 2. Well, actually, all of these are even numbers. So I'm going to divide every term by 2 just to get the numbers smaller and easier to do the arithmetic on. I have 1x squared minus 4x plus 4, and 0 divided by 2 is 0. So I can identify A, B, and C, and I can find the value for this discriminant. So b squared is negative 4 squared. Negative 4 times itself is positive 16. Minus 4, replace a with 1, replace c with 4, and we have that the discriminant is 0. All right, so if you think about that, return back to the quadratic formula, you have negative b plus or minus the square root of 0. So it's plus or minus 0. So your solution just becomes negative b over 2a. So it wants two things. It wants the discriminant. And it wants the number and the type of the solutions. So there's one, let's go ahead and call it a repeated solution. One repeated, well, I can make that repeated. Let's not complicate things by the fact that it's repeated. One real rational solution. Every other time, if the discriminant is different than 0, then it's going to be two solutions. It could be two real rational, two real irrational, or two complex. The only time that we have one real solution, the only time that we have one solution is when the discriminant is 0. And we're calling it a rational solution because we don't have a square root in our final answer. It's just a ratio of integers. That's what a rational number is a ratio of integers. All right, so let's take a look at number 5. It's in standard form, and I don't notice any common factor, so I'm going to jump in and identify A, B, and C, where A is 5, B is 6, and C is negative 4. So let's find the value for the discriminant. The formula is b squared minus 4ac. If b is 6, b squared is 36. Minus 4 times 5 times a negative 4. So let's do that calculation. I don't want to mess it up, so I'm going to do it on a calculator. I think it's 36 plus 80. Let's see, 36 minus 4 times 5 times the negative 4. Yeah, 116. And 116 is not a perfect square. Let's double check that, but pretty confident it's not. Right. If you take the square root of it with your calculator, you get a decimal number. So that's my discriminant. And the biggest mistake that people make about identifying this discriminant, you can probably guess what the mistake is. They do take the square root of it. See, look at what I've written in red here. I didn't write that radical. The discriminant is 116. And that gives us two real solutions, two real irrational solutions, because my final answer, when I do go to take the square root of that number, it's not a perfect square, so there's going to be a radical in my final answer. So it wanted us to find the discriminant and use the discriminant to describe the solutions. Well, our discriminant was 116. Since that's positive, we know that the solutions were going to be real numbers. Since it's bigger than 0, there was going to be 2 of them. And since the 116 is not a perfect square, the solutions are irrational. All right. Let's take a look then at this number 6. I notice it's in standard form and there's no greatest common factor among these terms. So I'm just going to come in and identify A, B, and C, and then find the value for the discriminant. The formula for the discriminant is b squared minus 4 times a times c. B squared, -7 times itself is 49, minus 4 times a, and a is 3, times c, and c is -6. So what do we get this time? Well, again, I don't want to make a silly mistake, especially on the video, so I'm plugging it. At school, I have an online calculator, and you can see how I plug it in, calculate and stuff, but here at home, I don't have an on-screen calculator. I get 121. Now, 121 is a perfect square because 11 times 11 is 121. So that's the value of my discriminant, 121. It is not 11. And this tells me, because it's positive, that my solutions are real numbers. And furthermore, since it's a perfect square, they are rational solutions. All right, so I hope that helps. And these 3 problems, they each had the different cases. The only one that's missing from these 3 examples would be if the discriminant were negative, and then we would have 2 complex solutions. So when the discriminant is 0, you have 1 real rational solution. When the discriminant is positive but not a perfect square, you have 2 irrational solutions. When the discriminant is positive and a perfect square, you have 2 real rational solutions. So that illustrates these different possibilities. I hope that helps, and I'll talk to you later. Bye.